So with this first one, right, we got this 2x to the 6th plus 1 over x cubed. A smart thing to do when taking derivatives is look at the function and ask, can I write it in a better way? Right, because a lot of times being able to do that makes life a lot easier. For instance, with this problem, or with this function, initially this thing looks like I should do a quotient rule. And if we remember quotient rule, that's kind of a pain, right? Quotient rule has all kinds of crazy stuff involved. But that is way too thin. Here we go. But if I look at this function a little bit and I remember how fractions work, right, I can split this thing up. And when I do that, nice simplifications happen. And then I can rewrite that second term instead of 1 over x cubed as x to the minus 3. And now what I'm looking at is just a bunch of power rule. And power rule is decidedly the easiest way to deal with derivatives. Okay, so if I rewrite f of x in this way, then taking the derivative becomes very straightforward. All right, and we can just leave it this way. This is acceptable. If you want to do one more, you can, but it's not necessary. Either of those is acceptable. All right. Hacking? Who's hacking? These aren't hacks. These are fun tricks. Making life easier is not hacking. Hacking is doing something incredibly complicated just to achieve a simple goal. Okay. So just to start off, not too complicated. All right, move on to part B. Okay, now that we've, done all of our useful things, I can ask, can I write this function in a better way? And the answer is, of course. All right, square roots really just mean fraction exponent. And then I can just flip it up and make it a nice, happy power rule again. And again, I can just leave it this way. Okay, questions so far? All right. So part C is where things start getting a little bit interesting. Because now we have a product rule, and I can't do anything sneaky with my function now. I kind of just have to do it. All right, so I need my product rule. Product rule says that my derivative is going to be the derivative of the first one multiplied by the second one plus the first one multiplied by the derivative of the second one. And we just have to remember that the derivative of natural log is 1 over x. And again, you can leave it this way. Never simplify unless explicitly told to do so. All right, never simplify unless explicitly told to do so, because in the simplification, that's where everything goes haywire. Right. Just doing it, not too bad, because we're just taking derivatives and then writing them down in the right order. If I tell you to simplify, then you're going to make silly algebra mistakes. Last year said that and marked me down for not simplifying. Well, that's silly. Your last teacher was silly. The one thing I'll say about my, I'll add a caveat to my never simplify unless told to do so. If your simplification is something like 4/2, you should write down the number 2. Okay, those are the kinds of simplifications that you should do if it's easy little arithmetic things. Okay, even this one, right, I would, if I read that, I would say, yeah, that's fine, but I'd be thinking in my mind, come on. But again, Dave was some, are you talking about Weisbart? Okay, let's move on to part D. All right. So here we have another product rule. Oh gosh. David is a character. All right, enough about David. Let's do calculus now. You all survived the math 5. Now we're going to do 9, which is decidedly better because calculus is much more interesting. Okay, so we have another product rule. All right, but there's 3 functions now. Okay, 3 functions worth of product rule. So we can still do it. We just have to decide, well, 2 of them should act as 1, and then we'll product rule from there. But we can be smart about this. And the way we're going to be smart about this is to say, see that one? X to the 4th times natural log of x. We did that already. That's part C. Okay, we already know that one. So that one we're going to choose to be one of them. All right, so when we say the first one, we're going to choose that product x to the 4th times natural log of x to be the first one. All right, so then f prime is going to be the derivative of the first one. And I'm going to color code things. So the derivative of the first one is what we already calculated. 4x cubed natural log of x. And then I'm going to simplify it just to make my life a little bit easier. Okay, so that's the derivative of the first one multiplied by the second one plus the first one multiplied by the derivative of the second one. And the only thing we have to remember is derivative of sine is cosine. All right. And again, we can leave it this way. We don't have to do any kind of bizarre simplification. Just leave it this way. Okay. All right, part E. Here we're kind of stuck. We have to do a quotient rule. There's no sneaky simplification things we can pull out of here. All right, so we're just gonna go for it. All right, so quotient rule. Maybe I should write down. Quotient rule says we need the denominator multiplied by the derivative of the numerator minus numerator multiplied by derivative of the denominator. And all of that gets divided by the denominator squared. And once again, we can leave it this way. Okay. If you want to multiply all that stuff out and then try to do some trig rules to make things look nicer, you are more than welcome to. I'm not going to do it because it's complicated and extra work that we don't need to do. If we plugged it in this way on WebWork, would it count it as wrong? It shouldn't. It definitely shouldn't. And the fact that you have unlimited attempts means it's worth a shot.
I have another quick question.
Yes.
So for the professor's quiz, this would be next week's quiz, I'm pretty sure. So
yeah.
Would he like us to leave it in this form, or do you think he's the one who likes simplifying it?
I don't know. That would be a question for him.
Okay.
In my experience, most professors like just this way because when they write out solutions, this is as far as they go. So when you're just taking derivatives of functions, simplification is an extra step that you don't need. If for some reason you have to then use it to do something, maybe take another derivative afterwards or plug in numbers or something like that, then simplifying might be a good idea. We're just taking derivative, not quotient product rule. Yes. Whatever homework you turned in on Friday is the quiz tomorrow. So if you have not yet turned in homework on quotient product rule, then you shouldn't be quizzed on it tomorrow. All right, that's the rule. Whatever homework you turned in on Friday is the material for the quiz the following week. Okay. But yeah, as far as the simplification stuff goes, ask him in class to see what he likes. I imagine that he doesn't mind if you leave it this way, but just double check with him. All right. Last one. This one, we can be a little bit smarter about how we make the function. All right, so 1 over cosecant x. We just remember what cosecant is. Cosecant is 1 over sine. And then using our knowledge of dividing fractions, this really just becomes sine of x. So they wrote sine of x in a bizarre way. So then taking this derivative requires not a whole lot of work. All right. A fun exercise, if you don't realize that you can write this function in a nice way, is to do the quotient rule on this thing with the derivative of cosecant and all that fun stuff, and then actually simplify it and see that you get cosine out of it. That's a fun exercise if you have some spare time and feel like doing it. All right. So now we're warmed up. Okay, we did these derivatives. We're ready to go and actually do something exciting. So that's number 2. Number 2 is exciting. So we have this function g of x, which is the product of the functions p and q. And we have the function h of x, which is the quotient of the functions p and q. All right, we're given some information about what p, q, and their derivatives do when we evaluate them at 5. And what we're asked to do is figure out what happens with the derivative of g and h when we plug in 5. Okay, so on the face of it, this looks kind of complicated, but all this really is an exercise in quotient and product rule. Okay, so if g of x is the product of two functions, right, to take its derivative, we need product rule. And so this is a really good problem to do to get the idea of what product rule does in general, right? We don't have any specific functions. We just have to know what product rule is. Okay, so g prime of x is derivative of the first one times the second one plus first one times derivative of the second one. Right? That's what the derivative is. That's what product rule says. But now we're interested in what is g prime of 5. So if I plug in 5 for x here, I plug in 5 for x everywhere. So g prime of 5 is going to be p prime of 5 times q of 5 plus p of 5 times q prime of 5. And wouldn't you know it, that's exactly all the information that we were given. So without even knowing what these functions are, if all I know is what they do when you plug in 5, I can figure out g prime of 5. So now we'll just copy everything down. Let's see, p prime of 5 is 7, q of 5 is 3, p of 5 is 2, and q prime of 5 is minus 4. And we work all this stuff out and we get 13. All right, questions about this first part? The important thing here is this. Okay, remembering what product rule does in general. All right, if you can write down this statement, then you can take derivatives of any product of functions that you want. Okay, this is the important thing. All right, now let's do the quotient. So h of x, right, is p of x divided by q of x. So to take the derivative, we need quotient rule. Okay, so just remembering in general what quotient rule says. Take the denominator multiplied by the derivative of the numerator, and then we subtract the numerator multiplied by the derivative of the denominator. And all that gets divided by the denominator squared. That's quotient rule. And then same thing. If I want to know what h prime of 5 is, I just replace all of my x's with the number 5. And again, we know what all this information is. So now it just becomes plugging it in. So let's see here. All right, q of 5 is 3, p prime of 5 is 7, minus p of 5 is 2, q prime of 5 is minus 4, all over q of 5 is 3 squared. Okay. And simplify, and we get, what do we get here? 21 plus 8 is 29 over 9. All right, questions about the quotient rule? Okay, so again, right, this was the important thing, was knowing that in general, what this looks like. Okay, so if you know that, if you write that down at the top of your page anytime you do anything, then you can do derivatives of functions that are quotients. Okay. Now we'll move on to number 3. So we have a similar kind of problem that we did before. Right, we're given this function f and this function s written in terms of this function g. Right, we don't know what the function g is, but that's okay, because we know what it does at 0. All right, and we're asked to figure out f prime and s prime of 0. All right, so we're going to do the exact same thing. Okay, except here, instead of a general quotient and a general product, we actually have a little bit more information. We have specific functions. Okay. So f prime of x is going to be the derivative of the first one, which is e to the x, and the derivative of e to the x is itself, which is nice, multiplied by the second piece, which is g of x, plus the first piece, e to the x, multiplied by the derivative of the second piece, g prime of x. Okay, so just another product rule. And then we'll do the same trick. If I want to know what f prime of 0 is, all I have to do is plug in 0 everywhere. Okay. I know what e to the 0 is, right? If I take a number and I raise it to the 0 power, I get 1. I know what g of 0 is because they told us. It's 3. E to the 0 is 1. And g prime of 0 I also know because they told us. It's 4. And last time I checked, 3 plus 4 is 7. Okay, questions about this part of the problem? All right. Second part of the problem is the quotient part. So I have my function s of x, which is that quotient. So to take the derivative, I need to use quotient rule. So I know it's not on the screen right now, but it's in my head, so just trust me. All right, so the denominator, 2x plus 1, multiplied by the derivative of the numerator g prime, minus numerator g of x, multiplied by the derivative of the denominator, which is just the number 2. Derivative of 2x plus 1 is just 2. All over the denominator 2x plus 1 squared. All right, and then same thing. If I want to know what s prime of 0 is, I just plug in 0 everywhere. Okay, let's see here. So I'm going to get 2 times 0 plus 1 times g prime of 0 minus g of 0 times 2 all over 2 times 0 plus 1 squared. Okay, so what do we get here? 2 times 0 is 0 plus 1 is 1. G prime of 0 is 4 minus g of 0 is 3. Number 2 comes along for the ride. And we already said that that thing is 1 squared. And we simplify. And what do we get here? Negative 2. 4 minus 6 is minus 2, divided by 1 is minus 2. All right. Questions about this part of the problem? If I'm going too fast, please tell me. All right. And especially tell me if I write down something that's not true. Okay, so at this point, if you're feeling that this is kind of getting a little bit boring and tedious because, yes, I already know how to do all this stuff because we've done it a million times, that's a good thing. Okay, it's a good thing if the reason is because I already know how to do this because I've done it a million times. All right, if it's boring because it's just the same thing over and over again, but you're not really understanding what's going on, that's not okay. All right, the idea with 9A and a little bit of 9B, but mostly in 9A, is you start doing the same thing over and over and over and over again, but with different functions. So much so that it starts to become just like, yes, okay, I'm going through the motions. I get it. Yeah, we're taking derivatives. We're plugging in numbers. Right? That's the idea, that you do it so much that it becomes second nature. Because the further you go, I imagine since you're all taking 9A, that 9B and 9C are probably going to happen in the future. Taking derivatives and plugging stuff in for these functions should become second nature, because at some point you're going to, taking a derivative becomes a very small step in a larger problem, and that's not the thing you want to get hung up on. So it's very important early on, right now, when we're starting to do all these derivatives, that if you don't know what's going on, if you don't understand what's happening, to say something, either during class, send me an email, come see me in office hours, whatever. Right? This is the early stuff. Okay, so this is the fundamentals that you really want to make sure you have down. All right, there's my spiel about derivatives. Okay. Now I'll move on to number 4. Number 4 has us doing, is it going to become second nature in the way solving for x is now? Yeah, that's what you want it to be like. Or if I throw an equation at you and say solve for x, you go, oh, okay, add 5 to both sides, divide by 7, boom, x is equal to 3. Right, that's how you want to feel when you're taking derivatives. Okay? If you don't feel like that right now, that's fine. Right, it's still early. Okay, but by the let's see here, we're in week. Are we in week 5? Yes. So this is week 5. By about week 7, taking derivatives should be just instantaneous. Right. So in a couple weeks, taking derivatives should just be like, yes, I get it. We're taking derivatives. Fine. Okay, because I think starting next week, you're going to be taking derivatives and actually having to do something with them. Okay. So you definitely want to make sure that you're okay with these things. All right. Okay, so now what we want to do is find this d squared y dx squared. Okay, and that's just a fancy symbol that says take the derivative twice. Do we ever do related rates? Oh, is that part of the standard 9A curriculum? It's been a while since I've done 9A. I don't remember actually doing related rates. I always think we're going to, and then we don't actually get there. So you're talking like the DRDT, DVDT, right? You got water filling up a bucket or something like that, like those types of problems. Yeah, I don't recall seeing that in 9A. So depending on how quickly professors go through the material, they might get to that, but I don't recall ever having seen it doing 9A. If you do it, it'll be at the very, very end, and it'll be like a day, and then it's probably not even going to get tested on it. So that's much more of a, I think they focus more on that in like AP calculus than they do here at the college level. They might do it in the 7 series because they care more about actual, like doing something with the calculus instead of appreciating it for being awesome. But if you get to related rates, don't worry. I will make sure that you understand them. I will do my best. Because even if it's a cone, you can still do it. You just have to figure out, where the numbers go. Okay. What are we doing? Oh yeah. All right. So this d squared y dx squared thing really just means take the derivative twice. Okay. So here we go. Take the derivative twice. All right. So if I take the derivative once, okay, we have this notation, right? Since it's written as y equals instead of f of x equals, we use the notation dy dx instead of f prime. And what that means is derivative of y with respect to x. Okay, so y is a function of x. We're taking the derivative of the function with respect to a specific variable, and that variable is the variable x. Okay. All right. So dy dx just means take the derivative of the function 1 over x. And maybe before I take derivatives, we can say, hey, 1 over x, that's the same as x to the minus 1. Make the function look nicer. Because now it's a power rule. So then dy dx, take the derivative, just becomes minus x to the minus 2. Okay, that's the first derivative. And leave it that way because we're going to have to take another derivative. And power rule is the best one. So if you can do power rule, do power rule. All right, so now we have this whoops, writing everything backwards. No, I'm okay. D squared y dx squared just means take the derivative again. So I take the derivative again, and it's another power rule. I get 2x to the minus 3. And as usual, you can leave it this way. All right, if you want to write it as a fraction, go for it. You don't have to. Just leave it this way. Here's your second derivative. All right, questions? It'd be a lot more complicated. Yeah, see, calculus is easy, algebra is hard. I'll say that a lot. I think I've already said it a couple of times during the quarter. Calculus is easy, algebra is hard. If you can make the function look nice, taking derivatives becomes not too bad. Right? And power rule is the best thing we've got. So if you can get a power rule to show up somewhere, that's good. As a fun exercise, I invite you to do this with quotient rule. All right, so instead of having this x to the minus 1, do it as quotient rule and say, okay, so it's x times the derivative of 1, which is 0, okay, minus 1 times the derivative of x, which is 1. So on the numerator, you got a minus 1 divided by x squared. Oh, and hey, that's exactly what that thing is. It's a minus 1 over x squared. Right? And see how much more effort that took to do it quotient rule instead of power rule. All right, so something else I say a lot, and this one sometimes makes people unhappy, but think smarter, not harder. Brute force is always a good method. It'll get you through what you're doing, okay? But there's no use in smashing down the door to get into the room if there's a window that's open. All right. Okay. Let's move on to part B. All right, so here we're faced with the function x squared times e to the x. No fancy simplifications I can do here, so we're just going to have to product rule. Okay, so product rule says we take derivative of the first one multiplied by the second one plus first one multiplied by derivative of the second one. And derivative of e to the x is just e to the x. Okay, there's our first derivative. All right, now we're going to have to do it again. Okay, and so now we have some options. First option, we can just do it. There's going to be 2 product rules, but that's okay. The other option is, hey, I see I can factor some stuff. You can do that. Why is it just 2x and not 2x cubed? Ooh, product rule subtracts 1 from the exponent. Right. Are you... Oh, okay. Right, or not product rule. Power rule subtracts 1 from the exponent. Maybe I said that correctly the first time. Too many words that start with the letter P. Okay. Yeah, power rule, bring the exponent down and then subtract. Okay. So yeah, second option is maybe we can factor some stuff out and then we have a thing and then do it again. You can do that. Another product rule is going to happen regardless of how you swing this. So probably just better just to do it. And maybe if we're clever, we might see something fancy show up. Okay, so now I take a second derivative, d squared y dx squared. Okay, so the first term I run into is this guy, 2x times e to the x. I got to take the derivative of this, and so this is another product rule. The second part is the original problem. Very good. So when we get there, that's exactly what I'm talking about. Yeah, so when we get there, we already know what it is. We can just write it down. Think smarter, not harder. Okay, so this first piece is a product rule in itself. So we've got derivative of the first piece, which is 2x. So that's 2 times the second one plus first one times the derivative of the second one. Okay. That's that piece. Now the second piece is exactly what we just did, right? That's the problem. That's the original function. I already know how to take the derivative of that. It's this. So I'll just write that down and not have to think. So that's 2x times e to the x plus x squared e to the x. And there's my second derivative. All right. Questions about this problem? Again, you could simplify if you wanted to. And by that, I mean these guys are the same, so we could add them together and call it 4. All right. But you don't have to. Okay. We could also factor an e to the x out of everybody. In the first part, why is it the derivative of both of them? Do you mean when we took the first derivative or the second derivative? So we took the second derivative. Oh, why do we take the derivative of this and this?
Yeah, so for the second part, or for the first part of the second derivative, the yellow part, isn't that the derivative of both of them? But e to the x plus x squared e to the x?
This is the derivative of just this part right here.
It's okay. Never mind.
Yeah. Right. So we did another product rule here where we called 2x the first function and e to the x the second function.
Okay.
Okay. Other questions about this problem? Okay. All right. We're actually going to finish today. That's good. All right. So here's the last one. Function is secant x times tangent x. I want to find the derivative evaluated at pi over 4. Okay. So I have all this trig stuff, and your first thought might be, hey, maybe I can make this look nice. And you can try. And, you know, when it comes to trig, looking nice is a matter of perspective. So secant x times tangent x, right? Secant is 1 over cosine, and tangent is sine over cosine. So really this looks like sine over cosine squared. So if you think that looks nicer, then okay. If you don't think it looks nicer, that's also okay. Personally, and this is just me, I hate memorizing stuff. I don't like remembering things. I have too much other stuff in my head to bother remembering things. And by that, I mean, you probably learned, and maybe you have written down, a derivative for secant and a derivative for tangent. Those are probably things you know, or at least can find. I don't remember what those are because that's just too much. There's 6 trig functions. That's 6 different derivatives to remember. Something I do know is sine and cosine. And I also know that every single trig function can be written as sines and cosines. So if that's the case, then we can do it with just sines and cosines. All right, that's one attempt. That's one idea. All right, so I'll write down that one way. Okay. One issue with that at this point is we don't have, I don't think, chain rule yet. And chain rule is what we'd need to deal with this thing. So the other thing we would do is use a product rule on these two quotients. Now we have two quotient rules inside of a product rule, which is kind of scary if you think it's scary. Okay, the other way is to just know what secant and tangent are. All right. So for the sake of time, I'll use the secant and tangent ones. And I invite you to either one, try the product rule with the two quotient rules inside of it, or once you get chain rule, do it on just that single quotient. Okay. So it's a product rule. All right. So I need the derivative of secant multiplied by tangent plus secant multiplied by derivative of tangent. Okay. The derivative of secant x is, what is that? Secant times tangent, I think is what it is. Yeah. All right. And the derivative of tangent is, I believe, secant squared. And someone tell me I'm right before I write it down. All right, derivative of tangent is secant squared. Okay, cool. Okay. And I want to evaluate this at pi over 4. So that's where things are going to get, we have to remember our trig now. All right. So because we have to evaluate, probably not a bad idea to try to simplify this thing a little bit. So I'm going to get secant x times tangent squared plus secant cubed. And I can factor out secant from everybody, and I get tangent squared plus secant squared left inside. Okay. And now I have to plug in pi over 4. So I have to multiply tangent by both secant and tangent. I did. This is just a product, right? It's just 1, 2, 3 product things. It's not a sum. I don't have to distribute. Okay, so now I plug in pi over 4. All right, so I'm going to get secant of pi over 4 times tangent squared of pi over 4 plus secant squared of pi over 4. And since we're just doing trig stuff now, I'm going to write down what it is, and you can trust me or not, and decide yourselves what it's supposed to be. Okay, that's what I'm going to write down because we're out of time and I don't feel like doing arithmetic. Why is it secant squared? So we had a secant cubed before, and then I factored out a secant. Alrighty. Okay, any last minute questions? Okay. As always, I will post this after class, so if you want to look at it again, it'll be there. If you have questions about any of these problems, you can always send me emails. If you have homework questions, you can send me emails or come see me in office hours. All right. Other than that, have a good rest of your week, and I will see you next week.